Okay, section 2 is about ratios and proportions. It's basically preparation for doing some of the problems that we're going to do in the next couple sections with similarity. So let's talk about ratios and proportions. First of all, what's the difference? Okay, is it the same thing? Are ratios and proportions the same? Ratios are basically fractions. Okay, so a ratio is like 3 to 2. It can be written like this. You can also write it like this, 3/2. That would be a ratio. Proportion is basically an equation. So it's an equation made up of ratios. So when we're looking at proportions, it would be something like 3/2 equals x over 5. That would be a proportion. Okay, and we can solve proportions using some of the theorems that are down below. So the first one I want to talk about is this one right here, the means extremes product theorem, or MEPT, which we'll need later on in the chapter when we're doing some proofs. Okay, so means extremes products theorem is basically if A over B is equal to C over D, then A times D is equal to B times C. We also know this as cross-multiplying, which we did a little bit of in the first section, cross-multiplying. Okay, and so like something like this problem up here would just be 15 over, equals 2x, so x is equal to 15/2. That would be solving an equation using the means extremes products theorem. The means extremes ratio theorem is basically the inverse of that. So if PQ equals RS, then P is to R as S is to Q. And the way I did that was I just thought about, okay, if I cross multiply, will I get what I started with here? Okay, so you can kind of work backwards into that. That also means that there's other proportions you could have written. For example, I could have flipped the Q and the P here, and I could have written Q is to R as S is to P, for example. Okay, and there's other ones also that you can write just like that. Okay, so let's talk about something called the geometric mean, or the mean proportional. These are the same. Okay, so a geometric mean is basically when you have a proportion, so like 1/4 equals 4 over 16, where these in this position in the proportion are identical. They're the same. So in this case, 4 is the geometric mean between 1 and 16. So if I wanted to find the geometric mean between 3 and 27, I would set it up like this. I would say 3 is to x, that's the geometric mean we're looking for, is equal to x over 27, and then I would solve for x. So x squared equals 81, x is equal to plus or minus 9. Keep in mind that when we square root both sides here, you end up with the absolute value of x for the square root of x squared, or square root of x squared. Now, don't confuse that with what we call the arithmetic mean. The arithmetic mean is what is commonly known as the average. So if I'm looking for the arithmetic mean between 3 and 27, I'm just going to take 3 plus 27 and divide it by 2. So 15 is the arithmetic mean between 3 and 27. Just as a side note, what this basically, some people are asking themselves, why are we doing this and what does it mean? So if you look at 3 and 15 and 27, and you think about this as the arithmetic mean, to get from 3 to 15, you're going to be adding 12, and 15 to 27, you're adding 12 again. That's what's happening when you're doing an arithmetic mean. When you're doing a geometric mean, you're going from 3 to plus or minus 9, and then to 27. You are going from here to here, and from here to here, and you are multiplying by the same amount. Multiplying by 3 here, multiplying by 3 here. Obviously, with a negative 9, you would be multiplying by negative 3 in both cases. So that is the difference between a geometric and an arithmetic mean. All right, let's move on and let's practice some cross multiplying. So here, for number 4 here, I'm doing some cross multiplying. I'm going to cross multiply this way. So I get x squared minus x, plus x minus 2 is equal to 18. And so x squared plus x minus 20 is equal to 18, or equal to 0, sorry. Factor this guy, and so you get x plus 5, x minus 4. So x is equal to, using zero product property, negative 5 or positive 4. Okay, so let's go after a few problems here just to make sure we're okay. Find the fourth proportional of 2, 5, and 7. So if I look at a proportion and I consider this the first position, second position, third position, fourth position, the fourth proportional would be this one right here. We'll call it x. Let's get rid of these little numbers here, lest I confuse you all. And this would be 2, then a 5, and then the 7 in this order. If I said find the third proportional, you would do 2, 5, x, 7 like that. Okay, but we're doing this one right here. You would cross multiply and solve for x. Let's jump down to letter D. Find the ratio of y to x. So that would be y to x, would be like that. If it said find the ratio of x to y, you would be finding whatever x over y is equal to. So y to x is equal to, and then you basically have to ask yourself what's going to give you this equation right here. Well, what would have to be on top here if I'm cross multiplying? The 9 would have to be here on top, and the 27 would have to be here on the bottom in order for me to, when I cross multiply, to get what we started with here. Okay, let's try one that's a little bit harder. Let's jump all the way down to letter I. Find the ratio of x to y. So we're looking for x over y and trying to find what that ratio is equal to. Cross multiply. If I have a negative sign here, I can either put it with the top or the bottom. Not both. Let's put it with the top. And so what I'm going to end up here is when I cross multiply, I'm going to end up with 40x minus 96 equals, and then I cross multiply these guys, negative 96 plus 18y. This nicely drops out. 40x equals 18y. And then again, I have to ask myself, This times this is going to give me 18y, so that means that the 18 has to go on top. Something times x is going to give me 40x, so the 40 goes in the bottom, and then I can simplify this. And I think you're going to get 9 over 20 as your final answer. Okay, one last problem here. If you want to challenge yourself, pause the video right now and try that problem. Find the ratio of x to y. If you paused it and you tried it, you should be doing something like this. Okay, hopefully you did that, but take ex, bring all the x's onto the same side, minus gx equals, I'm going to bring the y over to this side, fy plus hy, and then we're going to do something that you should have done last year, and that is factoring. So I'm going to factor out an x, so e minus g is equal to factor out a y, f plus h. And then we're going to go and do this thing again, where we're looking for x over y. You have to ask yourself, what times the y is going to give me this? So it's going to be f plus h on the top, and then it's going to be e minus g on the bottom. So that would be the answer to a tough problem, problem H there. Okay, hopefully that will get you a head start into this section. All right, give the problem a try. Good luck.